My name is Dan Votipka. I am an assistant professor at Tufts University. Today, I will be talking about some of the work that my colleagues and I at the University of Maryland did titled An Investigation of Online Reverse Engineering Community Discussions in the Context of Ghidra. So what is software reverse engineering? Well, this is basically just looking at someone else's code to figure out how it works. And this is important in the context of security because it's sort of a critical task in a lot of different things we think about in security, specifically in vulnerability discovery, as well as malware analysis. Reverse engineering can take a lot of, can be difficult and sort of an expert task. In prior work by Acton et al., they showed that even with small code snippets, it can take reverse engineers a long time to be able to reverse this code. And so there's been a lot of work to provide support for reverse engineering. There's been a lot of tools developed for sort of sophisticated program analysis. But unfortunately, prior work has shown there's just limited adoption of some of these more sophisticated tools among the reverse engineering community. And so in this work, we really wanted to understand more about reverse engineers' adoption of tools, understand what it is they're looking for and how they go about this adoption process, specifically looking at questions around looking at the way they discuss things in the public online forums. We had two sort of main areas of questions we were looking at. First, identifying the needs of reverse engineers from these discussions. So what is it that the reverse engineers are actually discussing the most? And then also we wanted to think about or understand better the dynamics of these communities, of the reverse engineering community. So how is knowledge shared and developed? And the idea here, by looking at these community dynamics as tool developers, understanding how the community works can help us know how to better support that community. In addition to these two research questions, we also asked an overarching question looking at sort of how the forum impacts reverse engineers' behaviors. However, for brevity, I won't be discussing that in this talk, and we'll leave that to you to review in the paper. Now, doing this kind of review with tools in the sort of public discussions can be really difficult, especially with the fact that tools have features that get released sort of iteratively. And so it can be hard to distinguish whether or not there's a lot of discussion about a feature because it's just been released or because it's something the reverse engineers are interested in. And so that brings us to sort of the key event that allowed us to be able to sort of answer these questions. And that was the release of Ghidra by the NSA. Ghidra is a fully featured reverse engineering framework. The NSA had been working on this tool for about 10 years internally before they released it to the public. So now we have a fully featured tool that has all the different components that a reverse engineer might consider in their process. And so the discussion that shows up in this sort of early adoption phase, reverse engineers, we can sort of, they're going to be focusing on the pieces that they actually care about, as opposed to having to worry about this sort of incremental update problem. In addition to this being sort of fully featured, there was also a significant attention in sort of publicists, or there's a lot of press coverage of this tool when it was released. There were several talks at DEF CON, Black Hat, and other security conferences, as well as a lot of attention to the press, and this led to a lot of discussion, which provides a lot of data for us to work with. So for this paper, we began by collecting all posts related to Ghidra from the 6 months, or in the 6 months following its initial release, its initial announcement. And this allows us to look at sort of this early adoption phase. We collected all the data from Ghidra, from Twitter, Reddit, and Stack Exchange, which is where we saw most of the discussion occurring. And we specifically only focused on discussions related to Ghidra features. So there were some things that we actually had to clean out of this collection. For example, the Ghidra logo looks like the 8chan logo, which led to a lot of discussion from the QAnon conspiracy community of people who believed that Q had released this tool as a way to combat the deep state. So once we did all this cleaning, we eventually were left with 230 Twitter threads, 62 Reddit threads, and 51 Stack Exchange threads. So now we have all of this data that's sort of unstructured text, and we want to turn that into something structured that we can actually do some quantitative analysis on. So first, we performed a qualitative analysis. Two researchers independently coded each of the threads and all the comments within them using a few existing code books, focusing first on the features that were discussed. We used all the issue labels that were provided in the Ghidra GitHub repository. And then looking at questions around community dynamics, we first looked at the way that these conversations were carried out. So what was the main reason for the thread? Was it a question? Was it an announcement of something? And what were all the discourse acts that made up the thread, all the comments that were part of it? Were they questions, answers, rephrasing a statement? And then also finally looking at whether or not the thread exhibited collective sense making. And this is the idea that multiple people are discussing some topic, and through that discussion come to build knowledge or build some greater understanding. So what do we find? Well, first let's focus on the question of what are the things that reverse engineers are discussing the most. So on that side, we actually saw that the most commonly discussed topic was actually not the tools themselves that Ghidra provided sort of baseline, but its ability to for reverse engineers to customize the features. This included things like writing scripts to extend the code analysis to add custom program analysis, as well as allowing for or providing for new architectures beyond x86 or ARM. Now, there was discussion about the main tool features, though this was statistically significantly less. And this discussion was actually dominated by comments about the decompiler. This is actually makes a lot of sense because this is sort of Ghidra's biggest feature in the fact that it provides a commercial level decompiler for free. Now, moving on to the community dynamics. Looking at how knowledge was shared and developed, we saw that a lot of this knowledge development came around question answering or asking and answering. So this chart here actually shows each of the questions that were asked to each thread that started the question, and whether or not there was an answer. So all the bars on the right show whether or not the thread was answered, and on the left in the grayed out space, whether or not they weren't ordered or grouped by the features that were being discussed, as well as the thread they were being discussed on. And here we can see that most of the questions were actually answered. So if you posted a question about Ghidra, you were likely to get an answer. But within this, we also actually saw an interesting phenomenon, which is that active responders were more likely to have their questions answered, which means that there was a group of people who were talking back and forth to each other, answering each other's questions. And so looking at this a little more, we graphed each thread on each of these forums as a node, and then we added an edge between nodes if there was a user shared between or who was commenting on both of those threads. And so this tells us whether or not maybe there was knowledge shared between these kinds of discussions. And what we saw was that there's in each of these forums a central cluster with many isolated threads around it, which sort of continues to show this idea of having a central group of people who talk to each other, work with each other, and then these isolated groups outside. In addition to this, we also saw that these active responders, these people in these central clusters, were much more likely to, these threads were much more likely to exhibit sense making. And so you actually see these types of discussions, people building knowledge in these central clusters. So from this, we have recommendations for both tool developers and the community. On the tool developer side, we think it's important to consider customization early to make sure that people who are users can extend the tools. Also important to sort of use the capital that you have for question answering on those isolated threads to help them understand how the tool works and adopt it. From the community side, there's good information on all forums, and it's also important to sort of incentivize bringing in those people from the those isolated outside groups into the central discussion. So with that, sort of in summary, we provided several findings related to the features and the community dynamics, as well as recommendations. I've included here my contact information. I'm looking forward to your questions, and I'm happy to answer your questions in the session following. Thank you.